Hi, I'm Marcus, and this is my presentation on Lake Nyos, a disaster that occurred in Cameroon, and this is my assistant Lexi. She'll be joining us for the duration of the presentation. So as you can see, it's Lake Nyos disaster, causes and prevention of a tragedy. I'll give you a little background on the location and geology. It's located in Cameroon, which is in Central Africa. It is close to the Nigerian border. And this is a region that is really known for its basaltic volcanic activity. And most of this volcanic chain stretches from, apparently my assistant is a little tired, stretches from the Atlantic Ocean right to, on a northeasterly pattern right up into Nigeria. So this gives you a little demonstration of what that is. So these are the volcanic island chains out here in the Atlantic Ocean, and it climbs right up. And here's the location of Lake Nyos right here. So a little more on the geology. These basins that form the lake itself are what are called a mar, and they're a volcanic explosion between the interaction of groundwater and lava, where pressure and steam builds up to the point where it explodes. They're relatively young, they're only 400 years old, roughly. Crater lakes such as Lake Nyos form in these mars. They're freshwater. And there are a couple nearby lakes as well, known as Lake Manu and Lake Kivu. Here's a little picture of the lake itself. So as you can see, this is the crater around the exterior, and then this is the mar itself. So what are the specifics? It's located about 1,200 meters above sea level. Has a maximum depth of 208 meters. It's relatively wide, 1,900 meters across and 1,100 meters wide, underlined by an active volcanic diatreme. So this is a description of a diatreme. So as you can see up here, you have the lake, you have some of the mar deposits, this is some pyroclastic flow that has subsided, and then this is your actual feeder dike, I guess is what it's called, is the active volcanic activity that feeds the magma up below the lake. And as you can see here is the crater rim. So duck and cover, the disaster specifics. So basically in August 21st, 1986, the eruption in Lake Nyos was triggered with the release of 1.6 million tons of CO2. The gas build over the northern lip of the lake, seeping into a valley below. This created displacement of the lighter oxygen, because the CO2 is much denser and heavier, and created an asphyxiation and death of approximately 1,800 inhabitants of the village below. Some of the warning signs that were exhibited to the villagers were rumbling sounds could be heard. Summoning people from their homes. When they reached the exterior, they found a white cloud and a surge of water rushing from the lake. The smell of rotten eggs was experienced just before passing out. And then afterwards, the color had changed to a rusty red color, and this was caused to be by ferric hydroxide. There was also found to be vegetation damage, and this was found due to surges of water that were 25 meters inland from the lake on the southern shore. This gives you a little contrast of what the lake looked prior to the eruption and afterwards. This is due to the ferric hydroxide. So here's another little description of what actually occurred during the eruption. Right here you have your diatreme, building up of the CO2 underneath the lake. During the eruption, all the CO2 rushed over this lip and followed down here into the village. And as I said before, CO2 is much denser than the ambient air, and that displaces everything and everybody suffocated. Here's a good description of the lake itself. So for all our limnologists out there, you have your epilimnion, your hypolimnion, and your metalimnion. In this lake, instead of being known as a thermocline, it is actually known as a chemocline. So this is where a lot of dissolved solids, specifically salt, accumulate. So divine winds, kamikaze, that's kind of the Japanese thing that saved them from the Mongolian troops, but it also did the same thing for most of the survivors in Lake Nyos, where anybody who was upwind or upwind from the eruption survived, and faithfully for those who were not, they did not. And now I'm going to hand it off to my assistant, well not assistant, my co-partner, Jazz, and she's going to give you a little background on the aftermath.
Oh, Lexi. So I have my partner here, come on back up, sit. Good girl. Alright, so the aftermath. So essentially, here we're going to talk about some of the effects and the side effects, kind of what happened after the actual day of the disaster. So, death toll. So here, this is just talking about, other than, we did say earlier that 1,800 people died, but what other animals and species were affected. So approximately 3,909 cows died, 3,324 fowl, 364 sheep, 561 goats. A total of 1,642 hectares of land was abandoned in the affected villages, including food crops such as maize, yams, groundnut, soybeans, which led to a high starvation of people in the area, because of course this area was actually known for their cattle herding. They had many, high amounts of cattle in this area. Alright, so side effects of exposure to CO2. So the majority of the fatalities that occurred as a result of the Lake Nyos disaster were found dead due to asphyxiation from the CO2. And some of the side effects were, most cases, we had blisters, acidic burns, and even though gases released were found to be predominantly from CO2, there was some speculation as to the cause being circulated, but how the systems arose was still actually not found, of why the CO2 affected, how the CO2 affected them. It is also noted because, of course, previously this had happened in Lake Monoun, which is another lake in Cameroon, that they all suffered the same side effects as the people did in Lake Nyos. And some of the other side effects that the survivors would display was difficulty breathing, headaches, and a number of numbness of the limbs. Okay, so managing the effects, so disaster management. So immediate post-disaster management was poorly documented after the Lake Nyos disaster for two reasons. One being lack of a culture of record keeping, and the second one is appointed relief managers did not want to be ostracized for their poor efforts. So this then brought in a presidential decree, created a national committee for the reception and management of relief aid. There were enormous challenges when having to give the disaster survivors what they needed. A lot of the donated items were not things that met the immediate needs of the survivors. Immediately after the disaster happened, rescue efforts were slow because at that point, no one knew what caused the mass deaths. So essentially people coming in, seeing dead people, they're like, what is causing this? And can it still be caused? So a lot of people were scared to go in that actual area. And so several of the 6 survivors ended up dying because they were left there to die. And so then eventually, a few days later, the army stepped in and did the bulk of the rescue operation. And due to the lack of the medical staff in Nyos, the health practitioners were brought in nationally and internationally. There are also a lot of broken promises in this case, and so what happens was broken promises were made when the disaster originally happened, such as pledges. Some of the promises that were made but not followed were pledges, health centers, schools being built, everybody getting 2-bedroom houses for each family. But even more than 25 years later, some of this stuff still has not happened. So that's just the broken promises. All right, so long-term management. So in Cameroon, the government started the Nyos and Monoun degassing project in order to mitigate the gas hazard in the lakes. So this includes continuous monitoring of the physical, chemical, and biological conditions of both lakes. So they installed carbon dioxide monitoring stations to give off warning signs if gas release occurs. And then degassing pipes were installed to remove gas from the Lake Nyos. So what is being done to prevent future disaster? So this is going to go into talking about these degassing pipes that happened. So since the eruption that took place, within Lake Nyos has recharged at an impressively fast rate, nearly 80 moles per meter squared per year. Making it evident that another eruption was likely to occur. So the gas levels were sitting at 97% saturation in 2001 with a pressure of 15.3 bar, which is approximately 226 psi. So that was in 2001. So what they essentially are going to be doing, so the degassing was done by installing a flow pipe to the gas-rich area of the hypolymium, where the gas could be stimulated mechanically. The carbon dioxide can then be dispersed in small amounts, in benign amounts. So essentially, the CO2 it will be dispersed into the air in effect in small amounts where it's not going to harm any more people. So they originally only did have one pipe, and then afterwards, and so that one pipe was actually bringing down the pressure about 25%. And so then it was predicted in 2001, after they put the first pipe in, that if they put 4 more pipes in, it could reduce the amount of CO2 from 75 to about 99%. And so this is just a picture here of one of the platforms where, so the pipe would be obviously under in the lake, and this is one of the platforms showing it's surge water, but the CO2 is actually being released from underground. So mix it up. So essentially here, so before placing the actual degassing pipes, it was crucial to deduce the stability parameters of the lake to avoid unintentional mixing. So essentially they didn't want to cause the lake to mix again on its own, or with what we were trying to do to install the degassing pipes. So enabled to do this is determined by measuring different properties such as temperature, salinity, and gas pressure, as is found that all relate to the horizontal stratification of the lake. Temperature near the benthos are warm, but gradually reduced towards the surface. This creates a dense water column above the CO2 rich in the hypolymium, acting as a barrier of hydrostatic pressure. This attribute can create a willingness to mix, as the warmer gas-rich hypolymium has an inclination to liberate to the surface past the denser water. So then dissolved solids, predominantly salts, are also located within the lake, forming a chemocline, like Marx had said before, and acts as a mixing retardant for the gas. Lexi. Regardless of this barrier, once the gas pressures have attained oversaturation levels, this confining layer can be overwhelmed and mixing will occur. And then, so then our references, and again, so all these references were used. You guys can go online and look at them for any further information. And that's it. Thanks for being impatient, Lexi.